Hello everyone. So today we are going to implement this fuse wire system. So as you can see here, as the wire get burned, you can see wire disappears and our particle system also going along the wire. So this is what we are going to work on today. This fuse dynamite fuse wire. So you can use this to implement something like a system where you ignite the wire and wire get burned until it reach the dynamite or the explosive. Here is the demonstration again. At the moment I don't have any explosives set up, so only this. So yeah, let's see how to implement this today. Right, first let's create a blueprint to represent the fuse wire. So I'll create a new pp folder and a new actor blueprint, pp fuse wire. Nothing is there at the moment, just the actor. So let me open the blueprint, and here to implement the fuse wire, first let's add a spline. So this spline will represent the fuse wire basically. So let me just press Alt and drag from one of these controls to duplicate the last spline point, so we can get a longer spline like this. And but if we go to the level, we see the spline but we don't really see a mesh. So now let's add a spline mesh here. To do that, we can get the spline, we can get spline points, get number of spline points. So basically we are going to add a set of spline meshes along this spline path that we have created to have the wire. So in order to add a spline mesh, for example, if I add a spline mesh here, you see we need to give a starting point, starting tangent, and end position, and the ending tangent. So basically like the rotation, not exactly but like the rotation. So to build a set of meshes that covers this entire length of this spline, we can do something like this. We can have a for loop starting from 0 and ends at the number of spline points minus 2. The reason to have minus 2 is because we need 2 points to add one section of spline. So if we consider the indices of these spline points, it will go from 0 to whatever the number of spline points minus 1. And since we have to have 2 points to add one section, we can't go all the way to the last point. We have to stop in the point before the last point, so that we have 2 points including the last point for the last segment. It will make sense when we create this. So add spline mesh component, and here as the static mesh, let's first set this cube and set start and end. So as I said, we need to give the start position, end position, start tangent and end tangent, which can be taken from this spline. So get position, get location at spline point, get tangent at spline point. So first let's take the first point. Let's take some space like this. Okay, similarly this point plus 1 for the next point. Okay, now start position, start tangent, end position, end tangent, compile. Now here we have this shape along the path we have, but this is too big, so we will need another mesh. How about this is not required, let me remove that. What if we choose, where is this? In engine content we should have shapes. Easier to find here. Cone. Basic shapes. Okay, here we have cylinder. Let's try that. Cylinder has to rotate. So actually we can do a simple trick. Let's export this as an FBX cylinder. I use the same name again, and in our content folder models, let me import the same cylinder I just exported. Right, now even if I assign that, it looks same, but we can rotate it using this import settings. What if we rotate it on x-axis? Okay, now this looks correct, but this is too big for a fuse wire, so we can make it smaller. See, now it looks correct. Alright, this part is done. Let me rename mFuse wire. So this is color. Let's make it white, more white, so we can clearly see it here. Now we need a way to make this look burnt along this path, or maybe just make it invisible if not burnt. But for now let's just have two colors, or we can use this. We can convert this to a masked material and have opacity mask. So how can we show only a half of this? Let's get texture coordinate to a component mask in G and add something here. So if I just connect it now, yeah, add 1. When we have 1 here, it's fully visible. If I have 0, it's half visible. If I have minus 0.5, okay, like this. If I have wait, if I have minus 1, it's fully invisible, right? I think we can use this property actually. Now we should see only half. We do starting from here. Okay, alright. Now what we can do is, let's promote this to parameter. Burnt level. Let's keep it 1 fully visible. Alright, we need something different, because if it is burnt it should be invisible. So if the burnt level is 1, it kind of doesn't make sense. So let's call it burn threshold. Same thing. Okay, now it's fully visible. So now what we need is a way to make it turn invisible with time, so that we can add some spark effect on the point where we see the wire last and move it along the line. That's the plan. But to do that, I need to have a reference to this spline mesh component. So let's promote this to a variable and break it. The reason I make it to easily create a variable with spline mesh component, convert it to an array via segments and that. Okay, if I make this visible, I should be able to see, oh, there are 12 meshes already. And as I update, you can see this count increases. So I think we need to clear it out, but need to check one more thing. Do we have valid component? Looks like we do. Okay, so I'll add a function clear segments. I'm not exactly sure these created segments stays, so for each if we have a valid component, let's call destroy component. Only if we have a valid one, otherwise we should not. And when it is completed, clear the array. So we always should have only the required amount of elements in the array. Clear segments, compile. See, only 3 elements. Even if we move around, it doesn't increase. Good. Now how do we implement burning? Well, here let's use tick for simplicity for now, but for if you have any performance concerns or anything, you can perhaps use a timer later on, but just to keep things simple, I'll use tick first. Right, now here what I'm gonna do is let's again from the spline get length and then get length this get distance along a spline at the spline point. So I'll promote this one to point index. Okay, maybe current index, so it will by default have 0, which is what we will have at the beginning, and I'll have another float variable burnt length. This should be a float variable, so this represents the length that is already burnt. That also should be 0 by default. Right, now get the burnt length, and if this is less than the spline length, so we have remaining spline or wire that to be burnt, and also if this is less than the current index, that means we haven't burned the first section, haven't burned completely the first segment of the wire. So branch here, so we know the current index. So if this is false, that means we have completely burnt the current index. So increment int, so we are moving to the next index. That means, so from the wire segments we can get the spline mesh component of the current index and set scalar parameter value on materials. So the value name is this burn threshold, and the value is, how can we calculate it? Well, we can get this length minus burnt length, but I don't think this will work, because to fully disappear we need to set this value to -1. Oh, actually that's because of this clip value. So if I set the clip value to 0.99, when the value is 0, we see only a bit. When the value is 1, we see fully. Right. So this method will work after all, but we need a value in between 0 and 1. So to get that, oh, one moment, the starting index should be 1. And here we should use, actually not index, let's call this point, because if we consider index, if we call it index, it has to start from 0. So when we get the mesh, we have to get from -1 point. To get a value in between 0 and 1, we have to divide this by this distance minus the distance of the point before this point. So this one -0. Sorry, this one -1, not 0. And use this value here. One more thing, we need to increment regardless of what happens here, we need to increment this burnt length. So set burnt length, get burnt length plus some value. Let's multiply this by delta seconds to keep the burning speed independent from the process speed. 0.1. We can change the values and find out what actually works best. Right, let's simulate and see. this is slowly, oh, this part stays visible, but that is something we need to fix. We need a mesh without this section, but you can see this is getting reduced. Maybe let's increase this like 10 so we can easily see the effect. Cool. Let's see a point where the segment changes. Okay, well, one issue is we see a small part. Other than that, it works. So why do we see this small part? Right here, before we increment, I think we can completely hide the previous section. So set hidden. This should work. Let's see. Great. We should disable casting shadows for this. So we can get rid of the shadow completely. Okay, nice. To disable the shadows, let's check here. Set cast shadows to false. Oh, we can already set it here. No need to add this option. Yeah. Because I don't think shadows are important for this case for the wire, but if you need to, you can leave it. Right, the next part is having the spark. I think in starter content we do have a spark particle. Why can't I add right? Add feature or content pack, content, starter content. Okay, done. Here we have particles. Oh, this spark is this color. We can change it. How about this one? This doesn't match. Let's use this one for now. We can modify it later, the colors. Just to see the scalability. In where should we put it? Sparks. If you want, you can create a separate Niagara particle and use it. For now, I'm just gonna go with this one. Maybe we should not activate it auto. We should activate it only in the big play. And as we move the burn length, we should get the base sparks, set world location, get the spline, get world, get location at distance along the spline. The distance is burnt distance in world space. And let's activate the particle in the begin play. Right. So once it reached the end, let's deactivate it. Alright, let's see the final version. See, nice. What if we move this up? Right, what if we let's modify this particle a bit. So instead of emitting particles only upwards, maybe we can here in this sphere, velocity distribution float constants. So how do we make it random? Okay, another point. Alright, I found it. We need to use distribution float uniform. Min -1 max +1. So now we emit all over the place. Max 500. This may be too much. And acceleration maybe a bit less. In action, it looks like this now. How about color? It should be something yellowish. Why does it become bluish again? Okay, I think this looks alright. So yeah, this is our fuse wire effect. So if you need, you can have like a advanced material which shows the burnt wire, or maybe you can just spawn some decals along this spline path, so you can show the burnt path. But for now I'm just gonna stop this episode right here. Alright, so thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.